All right, students, here we go. We're going to talk today about sequences, specifically geometric sequences, and we'll also talk about series. The difference between sequence and series, they're pretty much the same, except the series is when you're adding up all the terms of your sequence. So now we've already seen arithmetic sequences. Let's talk about geometric. So basically, geometric looks like this. Start with something like 5, then 10, then 20, then 40, and dot, 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 dot. Okay, so that is geometric. Okay, and the way we can quickly tell is looking at how you get from one number to the next. Okay, from there to there, there to there, there to there. So from here to here is timesing by 2. Okay, over here, from here to here is timesing by 2. That's what we're going to be looking for, is a constant change. So in this case, the constant change is times 2 times 2 times 2, and we call that a common ratio, and we'll use the variable r for that. Okay, so when you see r, it's referring to your common ratio. Like before, this is a1, that's a2, a3, a4, and dot, dot, dot. Okay, so what we're going to try and do is find out a formula for the nth one. Okay, so like if we want the fifth one, that's a piece of cake. We already know the fourth one, just times it by 2. But if I want the 10th one, I can't get that unless I know the 9th. But I can't get the 9th unless I know the 8th. Can't get the 8th, and so on and so on. So we could build it all the way up to 10, but let's say it was 100. You don't want to build it up to 100. So let's find a rule. So it's very similar to the arithmetic rule. What it is your a sub n is equal to, what did you start with? A1. And what did you do? Well, we times it by something called r. Okay, and so in the arithmetic, it was like plus n minus, or this thing times n minus 1, the starting amount, and then the difference times n minus 1. In this case, timesing it by r over and over, we're going to do repeated multiplications, exponent, and it's going to do the n minus 1 time. So let me make sure this is clear. Let's go very clearly about this n minus 1 part, because that's critical. Okay, what it is to get to the second one, you've multiplied by 2 one time. To get to the third, you've multiplied by 2 2 times. To get to the fourth, you've done it 3 times. So even though you're on the fourth one, you've only done it on 3 times. When you're on the third one, you've only multiplied 2 times. When you're on the second one, you've only multiplied by it 1 time. So what I mean is by the 10th one, you will not have multiplied by 2 10 times. You only had to do it 9 times because you didn't multiply. The first one doesn't get a 2 with it. It gives 2 to get to the second one. So it's kind of like if you're at step 1, how many steps to 10? There's 9 steps. There's not 10 steps. You started at 1, so there's only 9 more steps. So that's the reason for the n minus 1. Okay. If that's not clear, we will discuss it further in class, but I want to make sure we put it on this video and try and help you out because I won't be here in class tomorrow. So let's see here. So that's our rule. For ours, specifically for this one, we would say a sub n equals 5 times our ratio is 2, and we do that n minus 1 times. Okay, so let's do this and let's check. If you want the, let's say the fifth one, we know the fifth one should be 80. We know the fifth one should be 80 if we go next. According to this rule here, a5 is equal to the 5 times 2, and then we put to the n minus 1 power. So the 5 minus 1 power, or the 4th power. So that's 5 times 2 to the 4th. That's 5 times 2 to the 4th is 16. And 5 times 16 is 80. And 80 is what we expected to get up here. It does check. All right, so that's how you write a geometric sequence. All right. Okay, so now let's say we want to take the sum of that series, that geometric series. So we have a formula for arithmetic series. That's the formula from Gauss. We have the story for it, which makes it easier to remember. This one is not so easy to memorize. So let me go and tell it to you, and then we'll sort of work with it. This is the sum of n numbers. We just put S for sum. And how it goes is you just need to know the first term, and you go 1 minus r to the n over 1 minus r. Okay, Sounds worse than it is, looks worse than it is. It's not bad at all. Okay, where it comes from, that's a little bit complicated. So let's not focus on that right now, not in this video at least. I just want to talk about how to use this. So let's make one up. Let's say we started with 3, and then it went 12, then 48, and then whatever that next one would be. I'm going to cheat here because I'm feeling lazy. 4 times 48, because I want to do is multiplying by 4 each time. 192, and dot, 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 dot. Okay. So let's say that's our sequence. And let's say we wanted to go up to like let's go 10. Let's go to the 10th number, A1. This is already going to get pretty big, because you notice we're already in 192 by the fourth term. So by the 10th one, we're going to be pretty big. Okay. What's nice about this formula, the sum of 10 terms would be A1, which is 3, and then 1 minus R, 1 minus, again, got to know what R is. R is our ratio, or the difference between the two. We say ratio because if you took 12 divided by 3, that's a ratio, and that gives you 4. 48 divided by 12 will also give you 4. This divided by this will give you 4, and all the way through. So 1 minus 4 to the 10th power, because it's to the n power, divided by 1 minus 4. Okay, we could simplify all this stuff, but it's going to be something huge on top, because 4 to the 10th is huge. It's going to reduce with this negative 3 that we're going to have on the bottom. Long story short, let's just go ahead and type this in. Let's go and type it in just like that. 3 parentheses. And if you're going to do this, you got to be a little bit careful. The top needs to be separated with parentheses. 1 minus, you know what? I changed my mind how we want to do this. Let's separate the tops and the bottom. That would probably be even less work, less complicated. 1 minus 4 to the 10th. And that's negative 1048575. Again, we're going to divide that by 1 minus 4, negative 3. And then times that by 3. Final answer is what we get here, which looks like 1,048,575. And again, what's kind of tough about this is you're going to have a hard time verifying that's correct unless you write out the whole long thing, and that's a lot of work to do, like on a quiz or something. But I do suggest maybe you want to check it for some of those. Okay, so that's some of a geometric series. Okay, but there's also one more type of geometric series we need to talk about, and that's what we'll talk about right now. And that's something called an infinite series. Now, I know what some of you are thinking, how in the world can something that's infinite have a sum? And I agree. Except for it's something that you're going to get into calculus. We will talk about it in class, but again, it's something I don't feel like I can properly explain with this short video. There's tons of great explanations on YouTube, and we'll talk about some of them in class, but for now, that's not exactly what we want to go into. We just want to practice this. So, infinite series is something that obviously is infinite. So let's say something we had like 100, and then 20, and then 4, and then 4/5, and then 4/25, and then dot, 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 dot. Okay. So it's not, once you get into fractions, we don't want to work with fractions maybe, or maybe we don't mind them. What it is though, the ratio is just what's it doing to get to each one. And so, I should add the word geometric here to be proper. A geometric series is infinite. Geometric means has a multiplier. In this case, it's not multiplying, it's dividing. Well, could we think of that as multiplying by 1/5? Because dividing by 5 is the same as multiplying by 1/5. Then it's times 1/5, times 1/5, and then times 1/5. So that is our multiplier. That is our all right. So the formula for this thing, all right, this one's actually not too hard to remember. A1 over 1 minus R. That's it. Like, really? That's it. Okay. So for us, the sum of this infinite series is 100, because that's our first term, over 1 minus R, which is 1/5. All right. You might be surprised by the answer we're going to get here. It's kind of interesting. 100 on top. 1 minus 1/5 would give us 4/5. 100 divided by 4/5. That's 100. And to divide by a fraction, we multiply by the reciprocal. So that's 500 over 4, or just 125. Okay, that's it. That's all there is to these ones. So the infinite ones you might actually find to be less work. You might actually not mind this. It's not too hard of a formula to remember. But briefly, let's talk about the fact that you get a really nice round answer, yet what happened to these fractions? And so it's kind of weird, and we got a cool paper demonstration to demonstrate this in class that I'll show you on Monday. But what's happening here is you're adding 1 plus 100, sorry, 100 plus 20, plus 4. But then after that, each time, in fact, it's getting smaller and smaller and smaller. So even though it's infinite, you're getting smaller and smaller, little tiny pieces. So these little pieces at the end are just filling in very, very small things. It's sort of like if you had 0.9 plus 0.09 plus 0.009 plus, the amount you're adding keeps getting smaller and smaller and smaller. Okay. So this isn't related to this, but what it means, you could add this up forever and ever and ever, and there is actually an answer to that that we can talk about as well. And if you're still bugged by the infinite part of it, I would be more than happy to go over it and help share some other videos that might help. For now, let's ignore that. This is your solution. You now know how to do infinite series, regular geometric series, and how to write the equation for it. Now you know everything from chapter 8.3. You're ready to go on and kick butt on that homework. All right, have a great day. Thank you for watching the whole thing, and I'll see you in class tomorrow.